Howdy, I'm Kate Kavanaugh, and you're listening to the Mind, Body, and Soil podcast, where we're laying the groundwork for our land, ourselves, and for generations to come by looking at the way every thread of life is connected to one another. Communities above ground mirror the communities below the soil, which mirror the vast community of the cosmos. As the saying goes, as above, so below. Join me as we take a curious journey into agriculture, biology, history, spirituality, health, and so much more. I can't wait to unearth all of these incredible topics alongside you. Hello, everyone, and welcome to the Groundwork Podcast, formerly the Mind, Body, and Soil Podcast, though it all started as the Groundwork Podcast. We are exploring the threads of what it means to be humans woven into this earth, and I don't think anybody exemplifies this more than this week's guest, who is Helen Czerski. She wrote The Blue Machine, How the Ocean Works, as well as Storm in a Teacup, The Physics of Everyday Life, and is also the co-host of the BBC's Rare Earth, where her and co-host Tom Heap are exploring all kinds of amazing interconnected processes with some fantastic guests and having some great conversations about what it means to live on this incredible and rare earth. I just finished recording with Helen, and I wanted to jump on here immediately because I am so excited to bring you this episode. I could have talked to Helen for a good while longer, but I only had about 75 minutes of her time, and so we don't quite cover everything I wanted to touch on this interview, though. I really hope that it entices you to pick up The Blue Machine, to pick up Storm in a Teacup, both of which are fantastic on Audible. She narrates The Blue Machine, because I think that this really is about our deep interconnection to the cycles of Earth and the way that energy and atoms and the Earth's structure is flowing throughout this planet and throughout us at any given moment. I know that for my long-term listeners, you'll know that I love to talk about the way that nutrients, that atoms cycle through the soil, and Helen takes this a step further in how it happens into the ocean and the way that everything happens. And I'm going to pull this little quote that I didn't get to read on the podcast that I think is such a beautiful reflection of the recycling of energy that is happening every day here on Earth. And who better to talk about it than a physicist? This is Helen Czerski in The Blue Machine. This is the way the ocean does things, not as a one-way pipe, but as an unending cycle. One living creature's discarded material is reorganized, rebuilt, and reused by others nearby. All life on Earth, you, me, blue whales, sloths, the oldest tree, and the most fleeting phytoplankton cell, all of it is made from recycled material. There could be atoms in your body which were once a part of Julius Caesar, a Tyrannosaurus Rex, giant 2-meter long millipedes from many tens of millions of years before T-Rex, ancient grasslands, exotic iridescent beetles, and smoke from the early Industrial Revolution. The atoms that we're made from are completely interchangeable. Any carbon or iron or oxygen atom is equivalent to any other, and they move from one configuration to another, dancing through combinations and places and time with new surroundings at every step of the way. And I'll tell you that one thing that we didn't get to fully touch on was the interest in how often it is the waste products that really begin this cycle of life, which she has an fantastic exploration of whale poop in the book that I just can't get enough of this book, to be honest with you, and I'm sure that's coming through. You know, one of the things that we've been exploring a lot of lately is some ideas around circularity, around just how deeply interconnected everything on life is, and how everything that we touch on a daily basis has this origin point and these processes that underlie it. And I think that some of what I actually didn't expect to get out of this interview was some of how Helen thinks about the framework of how we ask these questions and uncover these processes. And as we point to at the beginning with a quote from Richard Feynman, how beautiful these processes are. And I hope that this episode invites you to cultivate a childlike sense of asking why until you can't find the answer, and knowing that there very well might be an answer out there, and that it is through these explorations that we can give meaning and perspective to ourselves. And as Helen puts it, perspective gives you a context for your value system. And towards the end of this podcast, Helen and I are really asking a question about how our society, how what we have come to know as our civilization is forming values and meanings of something like the ocean. And what I didn't realize was that when she wrote this book, she was asking herself what the ocean means, and to put that in both a human cultural context, to look at it as the ocean engine itself and just what an incredible breathing system it is here on planet Earth, as well as to tell the stories of some of those shareholders within the oceans, the animals, the humans, the bacteria, the atoms, honestly, the calcium ions, the coccolithophores, and how all of these machinations are affecting us on a day-to-day basis, and how our machinations here on Earth are affecting it in turn. I think that The Blue Machine is a beautiful exploration that will absolutely illuminate why we call this planet the blue marble, and to, as Helen so puts it, that we often see the ocean as an absence, and to really bring it into presence. And I think also to bring into presence water itself and the way that water systems work here on planet Earth and how tied in they are. And I think that this could not be more important, especially as somebody who grew up in a high desert, and as we consider water into the future, something that we've been exploring a lot of here on the Groundwork podcast, whether it's with Jay Owens and her book Dust, which is is really exploring water, or some of the ways we've explored water with Ben Goldfarb and his book Eager about beavers, something that Helen explores on her BBC radio show, The Rare Earth, whether we are exploring the way that our agricultural systems and phosphorus runoff with Dan Egan, who wrote The Devil's Paradox, affect the oceans and change them. And so we're looking at these bidirectional systems and ourselves as participators in those systems. And as Helen puts it, one of the best things that we can do is to begin to talk about this. And if you follow me on social media, you know that I am frequently discussing that I will turn up at a party and cannot stop talking about sand or beavers or whatever that may be. My most recent interest right now, I'm spending a lot of time going out and talking to everybody that I can about the ocean engine, because I just find it so fascinating. I hope that this podcast is a place, number one, for you to begin to explore your own curiosity, or to further your explorations of your own curiosity. And number two, to find these things to better understand so that you can care for them in a different way. And I hope that you'll continue these conversations with me off the podcast by dropping into my DMs on Instagram at Kate_Kavanaugh, or if you want to shoot me an email, kate@groundworkcollective.com. I love hearing from you. This is also a bidirectional system and a place where I really want us to be communicating one another together. And I am really appreciative of your listenership because it indicates your curiosity right alongside me. And I just can't get enough of some of these explorations. If this podcast has sparked a conversation in you, if you want to share this new perspective that you have gained, and we'll talk a lot about perspective in this episode, please share the podcast with a friend. 50% of all podcast listeners are found from word of mouth alone. And so you sharing this episode is one of the best things that you can do to spread the word. You can also leave a rating and review on Apple Podcasts or a rating on Spotify. This podcast is fully just produced by me, and your support is in your sharing. So please share it around. There's also a link to my Substack in the show notes. And I just really want to dive into this episode with Helen Czerski, author of The Blue Machine, How the Ocean Works, as well as Storm in a Teacup, The Physics of Everyday Life, and co-host of the awesome BBC4 radio show and podcast, Rare Earth. Here she is. Before we dive into this episode with Helen Czerski, I want to say a little piece about advertisements, which you'll notice are beginning here on the Mind, Body, and Soil Groundwork podcast. And as I've been thinking about what it means to bring on advertisers, I've been thinking a lot about support. And all of you know what an etymology nerd I am, and the origins of support are from the Old French supporter and the Latin supportere, sub meaning from below and portere meaning to carry. I think all of you know how much this work on the podcast lights me up and my genuine joy at what it is to share with you. The podcast is, however, a lot to carry. It is a lot to produce. It is a lot of research and care that goes into every episode. And it's really important that I feel supported in this work. And that's something it's taken me a really long time to say. I need support in this work, and it's important that I am supported because I think that this is doing such good in the world, because I think we are making so many connections. And so as I bring on advertisers, I'm thinking about this like an ecosystem, that we need these mutualistic and reciprocal relationships within our lives that help us carry the big bags of our dreams, if I'm being honest here. And the advertisers that I'm bringing on, what I am focusing on first and foremost is building a relationship with them and a relationship that I have built with you, and sort of building a bridge to connect those two spaces through something that I genuinely believe in, genuinely love, and genuinely utilize in my own life, and feel like they are in each of their respects supporting their communities and their ecosystems. And so with that, I am just so excited to have this sense of having someone to help carry this podcast forward into the world, into your ears as it does good. And it's a lot to produce this thing. It's a big piece. And so I would love if you would delight in this support in the same way that I am delighting into it, and show our sponsors some big love. And if these products resonate with you, please purchase them through these links, and that helps support the podcast. It supports me in my mission and my voice in this space. And so a big thank you to today's sponsors, Sundry's Farm Garlic, and our new sponsor, Redmond Real Salt, which I have been using for so many years. And I am so blown away by this team. They are a really, really special team of people that are bringing us something so foundational to life, salt, which we're going to see a lot of in this episode with Helen as we talk about the ocean. And so without further ado, and brought to you by Redmond Real Salt and Sundry's Farm Garlic, is Helen Czerski. I have a bit of a funny place to start. I thought that I'd love for you to introduce yourself, but I thought we would start with a little quote from Richard Feynman. I had dove into Freakonomics Radio's The Curious Mr. Feynman I had seen you post about it somewhere, and I love Richard Feynman and had thoroughly enjoyed it, and pulled a little piece where he's in discussion with a friend of his that's an artist and talking about maybe the way that artists and scientists might appreciate beauty in slightly different ways, though I think it's possible for all of us to appreciate beauty in both an aesthetic and a sort of processes reality. And Richard Feynman says, I could imagine the cells in there. He's talking about a flower. I could imagine the cells in there, the complicated actions inside, which also have a beauty. I mean, it's not just beauty at this dimension, at 1 centimeter. There's also beauty at smaller dimensions, the inner structure, also the processes. The fact that the colors in the flower evolved in order to attract insects to pollinate it is interesting. It means that insects can see the color. It adds a question. Does this aesthetic sense also exist in the lower forms? Why is it aesthetic? All kinds of interesting questions, which the science knowledge only adds to the excitement, the mystery, and the awe of a flower. It only adds. I loved this because as I traversed your work, I was really caught at how beautifully you illustrate both the beauty and connectedness of all of these different systems and life. And you traverse from the very small to the very big in time scales, from explosions and bubbles that I think are amongst the most transient of things to the deep time scales of the machinations of the ocean. And throughout all of it, you really retain this sense of participatory interconnectedness with the web of life and maintaining a sense of connection that I really appreciated. And so I'd love to talk just briefly about your background and maybe a sense of how this feeling of being connected led you to where you are right now.
It's a great quote from Feynman, and it gets used a lot, which I think I suggested it, that they use it on that podcast, because I thought you can't make a podcast about Richard Feynman without that quote, because he articulated very well something that I think should be obvious, and yet so often isn't. And it's this and the argument he was having with the artist is that the artist said, oh, you scientists, you make everything boring because you take them apart into their constituent things, and that is boring, whereas I look at the beauty. And I think the thing that Feynman said that I agree with is that beauty is kind of fractal. The more you look, the more there is. And
yes,
everything has a story behind it. Everything has something interesting. And one of the great things about being human is that we are curious and we want to know. And so basically everywhere you look, there's an interesting story. And of course, I look for the science stories because I'm interested in the mechanisms of how the world works. That's what gets me out of bed in the morning, really. It's like I want to know, I want to kind of see the clock ticking, if you like. I want to see the workings behind it. And because it's always interesting and it's always unexpected and it's always doing something much more intricate and fascinating than people normally give things credit for, I think. And so I guess maybe partly as a professional scientist, but partly also just because life took me that way. In a way, I've made a career out of poking around in the details and finding them interesting, and then trying to share all those interesting things with everyone else. And really, it comes from not being afraid to ask why, and not being afraid to think that ideas are connected to other ideas. And it was never really a big, there was never really some big, the word connection is used a lot now, but it was not used a lot when I was growing up, because systems were still, even then, people talked about systems separately, and now people talk a lot about connection. It's become a really fashionable word, but it wasn't back then. But it never seemed that, studying languages had to be different from studying history, which had to be different from studying science. Of course, they're all connected, and that's the fun, and that's the interesting bit. So you go poking around, you always find something like that. And, that's what I do, basically. I go poking around in the details, and then I come back with stories of what I found.
You do it so well too, and I think that you create a space that ignites others' curiosity. And I've explored a lot on this podcast the idea of asking that question of why, to deepen our inquiry into things, using that word in the same way that children do. And I love that kids will ask why until they've exhausted the knowledge of the adults around them. And I always wonder how I can turn that on within myself in a way that sort of uncovers these processes, which is another word I've heard you use quite a lot, that there is a sort of looking past the surface boundary of something and into what makes it tick, and then how that connects to everything else in a really fantastic way. And so I'm really appreciative of that. And whether it's the ocean or bubbles or explosions.
So I lost you a bit during that, but I think I got the beginning and end of what you said. But I've got an answer to one of the earlier bits, so I'll just carry on.
Great.
Yeah. So I think it's a habit, isn't it? That humans, as adults, we learn that the world is complicated and we haven't got the time to look at everything. So we learn to put blinkers on. And that, to some extent, is a practical thing to get through everyday life. You would never walk very far down the street if you got distracted by every paving stone and every flower in every car. So we're taught to filter as adults, to filter out the interesting questions, because they are a distraction from the important stuff of everyday life. That's the impression that's given. And kids haven't got that filter. And so really, like you say, all kids have this, and adults lose it. And I think it's a bad habit, because adults still ask those questions. And you hear it. I mean, most often in Britain, you hear it sometimes. It's usually at the pub, to be honest. It's a time when people think isn't important in a way, and they go, "Oh, I wonder why it does that." And then sometimes there's a debate about it. And these days, someone perhaps looks it up on Wikipedia. But the question, it's not that they're not there. It's that we learn to shut them down very quickly as adults. And we're taught to shut them down very quickly, instead of going, "Oh, why is it like that? I don't know. Let's go and, I don't know, if it's a seed, let's plant it and find out. If it's a thing that does something, let's do that." And it's bad to lose that habit. I think you need to be able to turn that door on and off. And so everyone's got it in them. I am convinced about that. But I think everybody lets the questions slide away very quickly. And then on the processes, I think one of the things about being human is that we have had historically a very sort of arrogant view of ourselves. I guess, if you go back in the history, you get sort of this this idea of humans being at the center of the universe, and you get these models of the solar system, which obviously have the Earth at the center, because why wouldn't you have? And then you sort of go through Ptolemy and Copernicus, and humans become sort of moved slightly to the edge, and then Darwin comes along and says, "Oh, well, we're just another animal, really," and humans get moved a little bit further to the edge. And that's not to say that humans aren't special. It's just that the history of science has been consistently showing us that there is something bigger than us. And the reason it matters here is that we still do it today, because we think that our time scales and our size scales are the only ones that matter. So people will look at a desert landscape, and it doesn't move for 5 minutes, and they go, "Oh, there's nothing happening here," and wander off. Whereas actually, if you look at either very fast or very slow timescales, or very big or very small timescales, there almost always is something going on. It's just that our particular speed of looking at things and size of looking at things isn't where it's happening. And I think that's another habit, that to be able to that takes imagination. You've got to know a little bit. You've got to know that, for example, what's happening in this desert is that maybe the dunes are being blown along by the wind in these beautiful patterns, and maybe there are insects that come out at night and go back, or whatever else might be happening in this particular desert. But you have to look at it on a different timescale, and then it becomes interesting. And I think that's the key to a lot of this, is that it takes a bit of imagination to understand that there are so many different pairs of binoculars to look at the world with. You can use, if you want to carry on with that analogy, you can slow things down or speed things up or make things bigger or make them smaller, or look at what they're doing now. And what they look like to different animals, and what they look like to different humans, and what would they look like if you could see them in the infrared, or if you could see them if you only knew they were there because of sound, for example. And so you end up with this sort of kaleidoscope of ways of looking at the world. And then it's just pick one, right? And obviously the privilege in this is that it helps to have had, the education to know how the world works. You've got a framework for thinking about it. Yes. That's the hard bit, I think. And that's the bit that that's what school education, there should a fundamental part of it should be about that. It's about providing a framework so that you know which question to ask to get to the interesting bit. And that's, but it is just a habit. But you do need. But now we have YouTube and Wikipedia, and I guess people like me write columns, and someone's probably thought about it, or someone's probably thought about something slightly to the side of it, and you can usually find out something interesting just by looking.
Maybe this episode about the ocean is making you as thirsty as it's making me. Some people say that we carry the ocean with us in the salt that's in our blood, driving our nerve impulses, muscle contractions, our water and mineral balance. As you're learning from Helen, the nutrient cycles of the ocean cover deep time as they work their way from land to sea, through the bodies of plants and animals, into the land, and back into the sea again. I want to take a moment to talk about a different sea, the Sundance Sea in Utah. Millions of years ago, in the Jurassic period, this ancient and mineral-rich sea was liquid, but today it has condensed into a layer of salt inside the earth where Redmond salt goes directly from mine to your table. This ancient seabed is packed full of 60-plus trace minerals, and you can find the breakdown on their website. And I love that it was around before the advent of things like plastics and today's pollutants. Redmond Salt's Relight Hydration Powder is one of my favorite ways to quench my thirst and fuel my curiosity and purpose when I'm diving deep into these topics on the podcast. In fact, I make it a ritual to have a glass full of Redmond during every recording. One pouch is packed with minerals, coconut water powder, and magnesium glycinate, a very bioavailable form of magnesium, which is why this is my favorite way to hydrate. The pina colada is wow, and my favorite go-to on these upcoming hot summer days. I can't wait to share with you all the other ways I incorporate their salt into my kitchen and everyday life in these upcoming episodes. You can get 15% off Relight Hydration Powder and all the other amazing Redmond Real Salt products using the code MindBodySoil_15 for 15% off Redmond Real Salt products by going to redmond.life. Again, that's the code MindBodySoil_15 for 15% off when you go to redmond.life or hit the link in the show notes. Let's stay thirsty for knowledge and hydrated in our bodies with Redmond Real Salt.
But it's interesting how I did a thing online a few years ago. So it was for some. So one of the things I do is this kind of. It's not even really an organization. It's a kind of group of interested in individuals called Cosmic Shambles. And I said, I can't remember why. I said I want to do an advent calendar, but I want to do an advent calendar where we put out on social media requests for people to send the most boring photo that they can think of. And they'll send. So this was in November. So we got like loads of people sent in like pictures of, I don't know, parking lots and I don't know, pebbles and things. And my job was for every day of December to write a blog about one interesting thing in that image. Picking a different image every day. And it was surprisingly easy. I recognize that I have spent a lot of years thinking about things like this and sort of perhaps having the habit of noticing things. But it really, because I did it and I thought maybe I'm going to be proved wrong here. It's going to be proved that there is a boring photo. But everything, because it's fractal, you just need a little way in, and then you're off into some story that links something to something else, whether it's, like rabbits eating their own poo, or the hydraulics of how car, what do you call it in the US? The trunk of a car goes up and down. Like, there's always something there. And it's just not being afraid to look.
I love that. I mean, a parking lot is sand and concrete, and there's an entire story there. And in every piece of that, there's a bit of a story. And I think you say at the beginning of the Blue Machine that you wish that you had some sort of device that allowed us to see the ocean in the same way that we are able to look through telescopes at space. And you mentioned these mini binoculars of changing time frames, which you have a whole chapter in Storm in a Teacup. And I think one of the things that I pulled out of your work as a whole is how often you speak to the idea of finding a different perspective. You use the word perspective a lot, and through a lot of different lenses. And I think it is that application of lenses for the very small, the very big, time scales that are very slow, that are very fast, and all of these different things. And I pulled a little quote here. And you said, putting ourselves in perspective is almost like a drug, but instead of inserting chemicals into our body, it involves mentally inserting our body into the universe and then standing far enough back to be amazed at the comparison. And so I do just wonder what perspective means to you. I think especially because what you've just said, and how frequently it reappears in all of your books.
Well, if you think about the contribution of scientists to culture, it's wide ranging, but I think it comes down to pretty much one thing. Because scientists, obviously, we like to think we contribute in lots of ways in society. We can help. Not me personally, because I'm not a medical scientist, but we can help produce drugs, for example, that might cure a disease, or we can help understand how to organize a traffic network, or we can understand, the biology of a frog, or there's lots of things that we can do that help us know things, and they help organize the world. But if you want the contribution of scientists to culture, to human culture, it is perspective. It's the idea. I think a lot of people think that, I actually hate the phrase science communication, because we don't have art communicators or history communicators. I don't see why we need, it's just communication.
Great point.
It's an expert sharing a thing. But anyway, but a lot of it is about, I have suddenly lost my point. Let me regain where I was going.
Take your time.
Yeah, so a lot of people think that it's about facts. It's about the communication of facts. That I'm going to tell you that a frog weighs 20 grams and it lives in a forest and it calls twice a day, or whatever it does. And there's this list of facts. And it's not about that at all. It's the fact that if you have in your head, if you've spent your time learning and studying, how things are and what they're doing, it gives you a different perspective on what's going on. And sharing that perspective, that is what scientists have to contribute. So when I'm, whether I'm writing or I'm presenting for the BBC or whatever it is I'm doing, if I'm asking the question, what can I contribute? Like, what is the thing that I can add to this situation which benefits somebody else? And it's almost always a perspective that comes from a scientific way of thinking. And it's just a way of looking at things. But you kind of need a bit of specialist knowledge to see it a bit differently. Everyone's got their own, the things they see in the world. Everyone's got different experiences. So everyone has a different perspective. But if you have a deeper knowledge of processes and what's going on, and the numbers give you the scales, right? Is it big? Is it small? Then you have a perspective that is different, and then you've got something to contribute. So I think it's interesting. And when you talk about how to explain, like you said, I wrote one book about physics, the physics of the everyday world, and the more recent one about how the ocean works. And really, the reason the ocean's an interesting case. Well, actually, both of them are interesting because no one had really tried writing a book about the physical nature of the ocean, right? People write about what's in the ocean, whales and pollution and fish and so on. No one had really looked at the water itself. And it takes, you need to know that there's something there. You need to know the physical environment. But what ocean scientists have mostly done in the past is share facts. They've said, oh, the ocean is 4 kilometers deep on average, or the ocean has this kind of fish in it, and those facts don't resonate with anyone. But if you introduce a perspective, like the ocean is an engine. It's doing things, and I can show you how they affected our history and our culture. Then you have a perspective. You have a way of thinking about the shape of what the ocean is doing that isn't just a list of facts, and that sticks with people. And so, this is what I don't know, this seems like good stuff to share. So this is what I spend my time doing. But it takes a lot of thinking. It's a lot of, none of this is straightforward. It's not, most scientists don't think about this. Actually, most scientists don't think very deeply about really how it relates to the world, because they're so interested in the technical aspects of it that they don't have the time often to take 2 steps back and think about what it means. And what it means almost always comes across as a perspective. But so Blue Machine was interesting, sort of slightly terrifying to write in a sense, because not only there were so many people who might like it, but there were so many people who might be annoyed by it. And it turns out the ocean scientists really like it. They come up to me and tell me they like it, which I did not expect. You do not expect your scientific colleagues to come up and you expect them to nitpick on the technical details, and they haven't done that. They've said, "Oh, I didn't know those stories." They didn't have that perspective on what they were doing. And so no wonder they can't share that with anybody else,
Yes.
So it was interesting to get stuck into that subject, because I mean, I study the ocean, I study the physics of the ocean. That's how I come at it. But I had to, I felt I didn't do a degree in oceanography. All my degrees are in physics. So I had to really work out what the ocean meant, from first principles. And I remember being annoyed 15 years ago that no one could tell me. And it turns out 15 years later, no one had told me. And so I worked it out and wrote the book, mostly because it was so frustrating that no one had said, this is what the ocean means. So I did it because I knew there was a story, but I also did it out of frustration that there's this huge, great big story. There's this huge perspective on what it means to live on planet Earth. Why is no one talking about it? So yeah, sometimes it's just born of frustration rather than anything else.
Perching above the Snake River in Idaho is Sundry's farm. Rob Croffle, adventurer, smoke jumper, and garlic farmer, as well as former guest on this show, and his wife Jillian Lukuski, who someday is going to come on this show, tend a plot of garlic in the rich volcanic soils of the Hagerman Valley. This isn't just any garlic, though. This is hand-grown, certified white rot-free garlic grown without herbicides or pesticides on a family farm. This is garlic that has been touched over 8 times as it was planted, weeded, harvested, dried, trimmed, and shipped directly to your doorstep. This is garlic with big, easy peeling cloves, my absolute favorite, that kept my dishes full of rich spice and warm earth all through the winter, and seed garlic that is poking out of the soil on my farm just now. This is Sundry's farm garlic. Comprising a range of soft and hardneck varietals for both culinary and seed garlic, Sundry's farm garlic is hands down and hand-grown the best garlic I've ever tasted. I love it for the ease of the big cloves and the bursts of big flavor, and I love it even more for the big, dreaming hands that tend it. Thank you, Rob and Jillian. Explore a wide range of varietals and grab bags for planting and culinary needs both by going to sundriesfarm.com. That's SUNDRIESFARM.com to pre-order your seed and culinary garlic for the year with shipping beginning in September. There's no code needed. You just have to have your hankering for some incredible hand-grown garlic ready and in action, and go to sundriesfarm.com. I'm really struck by that. I'm really struck by you saying that it was an exploration of what the ocean means, because it is, as you've put it, it's a collection of perspectives. It's also a collection of stories that weave in and out of one another that give picture to this machine that the ocean is, this living, dynamic, breathing machine. And I think also what it means in our connection to it, that it is not happening in a vacuum, and how much you tied humans into it in multiple different ways, both our effects on it, as well as our connection to it, even just from your vantage point in the canoe throughout the book. I feel that even the reader is able to gain a sense of close contact and intimacy with something that feels so unseen. And I think that's another piece of this, is that a lot of your work in the ocean in particular is uncovering these unseen processes. It's looking past the shape of something and into those uh, underlying processes that really give it that give it life and that tie us into it. And it's funny. I wanted to touch on this piece about the unseen because I've been reading Rose George's The Big Necessity. I don't know if you're familiar with
I
Rose
haven't
George's
read that
work. I
one.
think
No.
you'd like it. But it ties back into the history of sewers, which I think that you and I and Rose George
I can talk for a
share
long time about sewers.
bit of a
Yes.
passion for. But I wanted to kind of start with the ocean, with talking about something that we have marked as, and this is what you've said, as an absence rather than a presence, that it feels like something that is unseen, that it is in a way. It is the place where things go, and it is a way, and we don't know what it means.
Well, I mean, it's the presence and not an absence thing starts quite close to home, actually. So I live on the Thames in London, not literally on it, but just sort of 100 meters or so back from it. So I walk up and down it all the time and cycle, and it's very noticeable to me that Londoners treat the Thames as though it's not there. They sort of very carefully walk around it and over it and past it, and they don't see the thing itself. And it matters. So the Thames down here is an estuary. This is where it starts to open out to the ocean, and of course, this is why the City of London is here. It's England's gateway to the global ocean, and so it's tidal here. The tidal range just outside my window here is 7 meters, which is a lot.
Yeah.
Which is partly because of humans, but partly because it really is a massive, great big estuary with a lot of water going up and down it. But it is really fascinating to me and annoying to watch people avoid it. It's like a kind of blindness, that you can ask them what they think about London and what they like about London and where they go in London, and they sort of carefully avoid ever mentioning the Thames as a thing. They just talk about north of the river or south of the river, but they never talk about the river itself. It's only a relational thing. They'll talk about being to the side of the thing we don't talk about, almost. And if you ask them, like, when was the last time you actually looked at the estuary, they'll sort of, unless there was a seal, and you do occasionally get seals up here, they won't. They just, it's not. They don't think about it like that. And so it's the same with the ocean. It's this thing of being hidden in plain sight. Like if you, and it's really interesting because at the same time, if you take an aerial shot of London, the thing that everybody recognizes is the river. They recognize the bends. They identify where they are in relation to the bends of the river. But they don't, so they sort of use it. They know where this absence is, but they don't ever look at it. It's really weird. So anyway, obviously drives me nuts. But it's interesting even here, where you can see something where there's a huge tidal range. So there's animals doing different things at different times of day. There's different amounts of water at different times of day. It affects where you can go and what you can do, and they still don't see it. And it's right there, and it's ridiculous.
Yes.
And it's also partly because, and you get back to this kind of humans thinking our way of seeing things is the only way of seeing it. In the Thames particularly, it's because so estuaries are naturally brown, and that's because they're carrying sediment, and so it doesn't take very much turbulence to kind of mix up sandy sediment or small bits of clay, and so it looks a bit brown. So everyone just goes, oh, it must be dead. Just dismisses it because it must be dead. And yet I've seen, I've been at fish surveys down. So there's a very downstream of me. There's a very large, the sort of banking finance, the bit with the big glass buildings, called concrete and steel buildings, called Canary Wharf. Yeah. And right opposite that, I've been on fish surveys where they've collected, baby flounder and baby sea bass, and there's eels up there. The European eel, it's an endangered species, and it's right there. And yet, it's as though it wasn't. It's as though it's very frustrating. So so this business of things being hidden in plain sight. I mean, it's great for me because I can I can easily interest people by pointing at the things that are hidden in plain sight. Sometimes it feels like a bit like the Emperor's New Clothes, where the small child points at the thing that everybody sort of is avoiding seeing. And of course, most of the time, it's not like there's some nefarious thing going on. It's just that we're trained to have blinkers in that way. And I think sometimes it's good to take those blinkers off. Because it's interesting. And that's, that comes back to Feynman's point. There's all these reasons for knowing all of this, especially in the case of ocean and rivers. It's part of our life support system. It's kind of like if you want it to be healthy, if you want it to keep us healthy, if you're purely self-interested and all you care about is your own health, you still need to understand how this thing works so that it can do things for you. So, there's that side of it. And the curiosity kind of comes side by side with that. And they're both valid reasons for studying something. And yet we still manage not to see these things. So it's very frustrating. But it's easy to look. Everyone can point at a thing. And the habit here is just when you see like a duck do something weird, or you notice that somebody has longer strides than somebody else, for example, hold on to it, right? It's almost never a stupid question. Pretty much never, I think. I'm sure there is at least one stupid question out there, but I've never, very few met it. And the thing about the strides, actually, by the way, is that our legs are pendulums. So the way we walk is that we lift one foot off the floor by lifting a hip slightly, and then we let our legs swing. And then when it's swung to the other side, we put it down again. And it is the nature of pendulums, and this was discovered a long time ago, several hundred years, people observing pendulums swinging, that a larger pendulum, a longer pendulum, swings more slowly than a small pendulum. So if you've got short legs, your stride rate will be faster because your pendulums don't take as long before they get to the end and it's time to put your foot down. So even walking down the street, you can see these things. And so if you've ever wondered, I wonder why some people have longer strides than others. It's not just because some are tall and some are short. There's a more interesting thing in there, and you can always dig about and find it.
I love that you brought that up. I'm a walker. I walk many, many miles a week, and so I'm always thinking about walking, and you do such a great job of that. I just recall there's a point in Storm in a Teacup where you discuss why a pigeon's movement is the way that it is, and I think
pigeons
that
are great.
Pigeons are great, and it's really surprising to sort of uncover that. And I think to that point, something that you come back to is a quote by Lacey Veach, who was a NASA scientist, that says, you can't protect what you don't understand, and you won't if you don't care. And I think that when we remove those blinkers and learn to remove those blinkers even too, because I want to speak to that there is sometimes a process of learning how to ask why again, or how to cultivate that sort of childlike sense of asking why, and reveal the inner workings of our surroundings, and especially those things that are unseen right outside our door. I fancy myself a bit of a citizen soil scientist, and I've spent a lot of time thinking about soil, which I don't think is unlike the ocean in that it is very omnipresent and very there, and yet very glossed over. It is an absence and not a presence. And
part of the habit of asking questions, I think, is knowing that there is an answer, is having the confidence that there's an answer. Because I think that stops a lot of people asking, is they assume that it's just because that's an answer we get. Oh, it's just because. And therefore there isn't anything to ask, right? Why would you ask why if there isn't an answer to that question? The thing with the pigeons, by the way, for anyone who has not spent a lot of time looking at pigeons recently, is that you may have noticed that pigeons sort of bob their head as they walk, but actually they're not really bobbing their head. What is happening is that pigeons see the world very slowly. So they kind of need to look at something for a long time to build up enough of a picture so it's not all blurred. So what they do, and obviously if they're walking forward, they're kind of blurring the image all the time as they walk. So what they do is they shove their head forward, and then they keep their head still while the rest of them walks to catch up. And so the head has stayed in the same position for long enough to get a good idea of what's going on. And then when it's kind of collected that picture, and its legs have caught up, then it shoves its head forward again, and then its legs catch up. So that's what's going on with the pigeon. And the thing that is brilliant about this is that the paper where they studied this has one. So it's not often that scientific footnotes make me laugh out loud, and there should be more of them, I think, in proper scientific papers. But the people who did this did the most to discover this image, this thing that pigeons do. What they did is they put pigeons on treadmills. Do not ask me how the training for this worked. But with the motivation for that is that if you put a pigeon on a treadmill, then as it's walking, its surroundings are staying the same. So they don't bob their heads when you put them on a treadmill. Their head just stays in the same place, and the pigeon walks, and it all sort of, there's no need to bob its head. But what the footnote said on this paper was that they had this experiment with the pigeons and I want to see this lab, by the way, with the pigeons.
Oh, me too. I couldn't stop trying to picture it.
Is that at some point they turned off the treadmill, and the pigeon was just standing there, but they hadn't turned it off fully. And so very, very slowly, the treadmill was still moving backwards. And what happened was that the pigeon just slowly stretched its head, so the image stayed the same until it fell over on its beak. And just, and then you've got a whole other set of experiments, right? Because it was clearly, even though it wasn't probably consciously aware of it, it was keeping its head in the same place. So it didn't know the treadmill was moving too slowly for it to really realize it was moving backwards. But at some point, it just keeled over, which is also a video that I would love to see. So, these little. And the thing about these little things is that they always bring joy. One of the great things about being human is that if you tell anyone these little things, like, everybody loves it. They remember it. They go and tell their friends. It changes how they see the world. And by telling something that is memorable, you also encourage people to think, oh, maybe there is an answer. So then it's worth asking the question. And then the hard bit is just finding someone who knows the answer, or knowing how to work it out for yourself, or where to look it up. But you can always ask. There's almost always something interesting there. It's just the habit, I think. So I think, even now there are answers that are still not known, plenty of them actually. And a category that annoys me quite a lot is that, well, I find it frustrating, I guess, is that there's a lot of physics questions about animals that biologists haven't answered. Because a biologist who is not trained to think about physics, if a frog makes a noise, it just goes, oh, well, it makes a noise. And I've got this question. So what's it doing to make the noise? Like, what is actually happening inside the frog to make a noise? And sometimes you go looking for these things and no one's worked out the answer, right? Because who is going to fund us? Although I think they're good questions. Funding agencies apparently not so keen to fund scientists just to go off and say, well, why does a frog do that? So sometimes it happens. But there are a lot of interesting questions that actually we don't, science doesn't know the answer to all of these things yet, but we can still look at it and learn interesting things by asking.
I think that you bring up something that I hadn't considered asking you, but I do want to ask now that it's here, which is, you talked about at the beginning that oftentimes scientists will become so interested in the technical details of something that they might not zoom out to that bigger picture of what it means. Do you think that there's also a space where different disciplines aren't speaking to one another, biology and physics, for example, that don't allow for some of these questions to get explored in that way? And I'm thinking about, I have a friend who's currently at UC San Diego and is really interested in looking at the way that physics relates to the olfaction in sharks, and how they're able to pick up such tiny molecules in such a noisy place as the ocean, and how physics might apply to that situation. And so I think there's a question in there of, if we have more interdisciplinary communication, for lack of a better word, does that help to illuminate some of this? And also, one of the things I really love about your work is it puts physics in the everyday reality of our objects, and out of a vacuum, and out of a theoretical perfect place, that nature is the most interesting place to explore this. And I have this little quote from you. The end of it is, our definition of exploration now has to be about processes, about humility, and sitting in a place where we think we know what's going on and watching nature prove us wrong, which I loved.
Okay, well, there's a lot there. On the interdisciplinary thing, I think that it's not that scientists don't want to or don't have the time. I think it is that they don't have the time. I think it's that what we have done is professionalize science in a way that makes it all about goals and endpoints, and professional science has largely had the fun taken out of it, in a sense that, we have to get grants in order to get money, which is taxpayer money, right? You have to be studying something which is going to be useful to somebody. And so there is generally not very much money around for studying stuff just because it's interesting. And there is a bit, in both the UK and the US, but it's very, very, very hard to get it just because it's interesting. Like almost no one will. They'll say they'll fund you for that, but they won't. So, so part of the problem is it's not that all these scientists don't or can't talk to each other. It's that we've built a system which focuses on goal-oriented science, and the problem is that narrows down the possibilities. And of course, it's drastic. It's a very short-term way of doing things, because the interesting things always come from the thing you hadn't thought of, and you're much more likely to find the thing you hadn't thought of if you're a physicist talking to a biologist, rather than if you're a physicist who's doing making an incremental step on what they knew before. So I don't think it's to do with the organization of universities or interdisciplinary conversations. I think it's that the way we fund science squeezes that out almost completely. Because if you want to survive in science, you have to do some work, which means you have to get some money to do some work. And that means that you need to write the kind of thing that's going to get you the money, be asking the kind of question that's going to get you the money. And what governments funds? I mean, let's not be sort of there's no government in the world that I know of that really funds science for its own sake at the moment. What they fund science for is because it's in the national interest, but mostly in the short term. And the more enlightened ones realize that, of course, you don't know in the short term what's going to be useful and what isn't. So you need a broad foundation of science done, because then when you need the thing that will turn out to be useful, then it's already there. And so this funding model of science, where you try and pick winners, you try and pick the thing that's going to make the next big tech company or whatever. I mean, it's kind of doomed to fail if that's the only thing you do, because you need to have this broad foundation of here's all the things that we're sort of exploring, and we understand that we're investing in this because it's all going to come in useful eventually, probably. But it's not got an immediate application yet. So yes, interdisciplinary conversations are great. But it's not that we can't have them, or it's not that we don't have them, really. It's that we are incentivized not to have them because we haven't got the time, because the other thing that all scientists are is too busy to think. So there's that. And then you asked me about a quote.
I had the piece about where our definition of exploration now has to be about processes, about humility, sitting in a place where we think we know what's going on and watching nature prove us wrong.
So the exploration thing is something I feel quite deeply, actually, and it's born of I guess it's kind of reaction against colonialism, in some sense, a type of scientific colonialism, which says that if you go there and you draw it and you stick a flag in it, then you've done all you need to do, and you can now just clear off and go and draw the next one. It's this habit, this idea. We've got a culture in the Western world which has told us that what exploration is to go far away on a ship for the benefit of some king, probably, and to discover some new land, new in inverted commas usually, and then you give it a name, you do the mapping, so it's got you sort of give it a geographical shape, and then you stick a flag in it and you clear off back home, and somebody gets some extra gold. And the problem with that view of exploration is that it's extremely superficial, and it focuses on conquest. Because it's based on the idea that if you draw the map of it, you then somehow know everything and you sort of own it somehow. But you don't need to do anything else to deserve owning it. You just you sort of own it because you know about it, in the sense that knowledge is power, which was very much 400 years ago. Knowledge very much was power. So we've got this idea of what exploration is based in that. But now, and I still get it really depresses me. I do sort of talks for school children, that kind of thing, and I still get the question, are there any parts of the deep ocean that haven't been explored? And I kind of want to, I kind of want to take whoever gave them that idea by the scruff of the neck and just make them take them into some, rewrite their view of what history is, because exploration is not about we're going to draw a line behind it, around it, and then we sort of own it and we tick the box. We've done everything we need, because that's not even the start. That's just knowing where the start is. And then it's about what is happening. It's having the humility to hang around and to watch for processes that you didn't know were happening, and to try and understand what's happening on the timescales and the size scales that are not yours. So you've basically got to make yourself small. And so you've got to invert this idea of exploration from making yourself big, from being the big explorer who planted the flag and who has it named after him, to making yourself small by putting yourself inside a system and just watching from the inside. And so, of course, plenty of the ocean has been mapped, but that doesn't mean it's been explored. I mean, we're doing our best. A lot of ocean science, it's not, I've got a whole bee in my bonnet about that thing about knowing more about the deep sea, the moon, than we do about the deep sea, because it's not true. There's more to know about the deep sea by a lot. But the point is, there's always something to explore. Exploration doesn't end. So it's, I think, both for, post-colonial reasons and just because it's common sense, this word explore, we really need to turn that on its head. We have to get away from this idea of it being a bloke with a, gun drawing a map, because that is not what exploration should be.
I love that. I'm really appreciative of that, because I think that so much of this is about exactly what you said. It's about the humility to make ourselves small and to observe on time scales that are not our own, as you so perfectly put it. And I'm very appreciative of that, because I agree, and I think that there are ways in which our language, our colonial language, in terms of how we view the word explore, even has shaped us, but also how maps have shaped the world. I was struck by that. On the British cover of your book is the Spillhouse projection of the oceans, which I spent a long time staring at, because it just absolutely upended anything that I felt like I had ever seen or known in terms of just the shape of something, much less the processes that underlie it. And so I think that so much of what we are taught shapes our view of things, and some of this maybe taking off of the blinkers is to find a different perspective.
And I should say that I love maps. Maps are really important, and I love that framework for the world that they give us. So it's not that I don't have a problem with a map at all. I just have a problem with the map being seen as the end point.
Yes. I want to take a little bit of a turn, and I want to dive into the ocean a little bit, and I want to touch on something that I think been exploring a lot here on this podcast and in general, which is some idea about circularity and energy. And since I don't have the pleasure of talking to physicists very often, I would love to explore a little bit, especially around the recycled energy of the ocean. And I have a couple of quotes here, and maybe first we ought to just give just a short primer about the ocean engine and just how much it's tied into everything. But I have some fantastic little pieces about how much recycled energy is in the Earth system and then the ocean system as well.
Well, so that physics is fundamentally the study of energy and stuff being matter, atoms. And energy moves around and it makes atoms do things. That's basically what the universe is. And so I think there's two fundamental rules to planet Earth. And what Earth is a big ball of atoms, and it's mostly spherical and it's spinning around in space. And it's extraordinarily unusual to have a big ball of this many different types of atoms. I mean, most of the universe is hydrogen followed by a bit of helium, and the sort of stuff that we see around us is unbelievably unusual. It's absolutely exceptional. And we've got this big ball of it, all these different metals and, gases and all these very different types of atom in very large quantities. So we've got this ball of stuff that energy can get to work on. And so the way that this planet works is that energy comes in from the sun and it arrives. That bit's quite easy in sunlight, and it might get absorbed by different bits of the system. It might warm up some ocean water. It might warm up some rock. It might get turned by a plant via photosynthesis into stored sugars. It could become stored chemical energy that way. It could power winds. It becomes energy in all kinds of different ways. And it sort of hangs around the Earth system, making all the atoms move. But then the bit we don't talk about is that if energy just kept arriving and it never left, then we'd just get hotter and hotter and hotter and hotter. And so that doesn't happen, because if that had been happening for 4.5 billion years, which is the age of Earth, then we'd have all have boiled away into space by now. So what happens is that because the Earth is warm, it radiates heat away. Just like if you put your hand near a warm fire, you feel heat energy coming off it. That's infrared light. Everything that has a temperature is giving away its heat slowly. It's kind of radiating it away into space in the form of light that we usually can't see. So the Earth is glowing. So what is really going on is that energy is arriving at Earth and it hangs around for a bit, and then sometime later it is radiated again away into space, and it continues its journey out into the universe. So we're just a kind of reservoir that hangs onto it for a bit. And then while it's down here on Earth, it can be doing all these interesting things because it pushes atoms out of equilibrium, and then everything then tries to readjust itself. So energy is like giving a system a kick up the bum, basically. You add in some energy, you kind of displace something, and then it's got to do something as a consequence. And so the Earth engine runs on the sun's energy. So energy is constantly flowing through. And then, of course, the ball of atoms that we've got, the atoms, unless we launch some rockets and things like that, they stay here on Earth. So they're constantly recycled around the system. The copper, for example, that is within you and I was previously part of a plant, which was previously part of a rock, which was previously part of something else. You sort of go back. So all the atoms go round and round. So those are the two rules of planet Earth. The energy is constantly flowing through and the stuff is going round and round. And then you have to ask, so this starts to sound like an engine, right? Because you've got heat energy effectively that is making something move. So how does this engine work? And when you look at it, the most important physical component of it is the ocean, because liquid water is very, very weird. Liquids are unusual in the universe. So we've got all these unusual atoms already. And then we've got this big bunch of them, which are in a liquid form, which is odd. But liquids can do very interesting things. They're very good at storing energy. So water is exceptionally good. If you give it a bit of energy, it heats up a little bit and it will hold that energy as heat. But it can also flow around. So you get ocean currents, and you don't just get horizontal currents. You sometimes get water that moves down and up through the ocean. And so you have this three-dimensional overturning engine, which is what the ocean is doing with most of the energy in Earth's reservoir. And then, of course, all the other energy is, making the weather and helping plants grow and all that kind of thing. And so this engine, the way that it turns is distributing heat around the system because it's this liquid engine. And not only is it moving heat energy around, it's also carrying other things. So it's carrying nutrients, for example. It's carrying it's carrying atoms of different types. It's carrying life. And so it's carrying things around as it's turning, and that delivers stuff to us. And, so you hear on the news sometimes, certainly here in the UK, in a coastal area, you hear occasionally they'll say, oh, well, today hundreds of thousands of jellyfish washed up on the shore of Cornwall somewhere, as though the jellyfish just kind of appeared. Today there's jellyfish, tomorrow it might be clarinets, the day after that it could be, I don't know, clocks. And it's spoken as though it's just this random event. Oh, today there's jellyfish. And of course that's not what's happening. What's happening is that the ocean engine underneath has turned in such a way that it has brought the conditions for life somewhere near the coast. And then they appear at the surface, which is probably not where they were before. And then people go, oh, there's jellyfish. But actually, it's just you're seeing just the surface of a three-dimensional engine turning underneath, and some part of it has just popped up to the top. And then humans notice it. But it's not because it's random. It's because of what was happening underneath, and you're just kind of seeing one part of it. So that's the basic idea. The way this engine turns, first of all, makes life on Earth possible, but it also, even if you live a long, long way from the ocean, the way it pushes around energy influences you. It influences where you can live and how warm it is and what lives there and what comes and goes through, what migratory birds you get, all that kind of stuff. And it influences our culture and our history. Like I said, I live on the Thames in London. The reason London is here is because the ocean is there. If the Thames didn't go anywhere, there wouldn't be any reason to have a big city here. But because you can go out on the ocean and get things and trade, and we've got, a shallow sea, which was very full of fish 1,000 years ago, so that was useful. So you get communities that are built up where the fish live and where people can trade and where, and so once you start to look at our history and culture, it's enormously influenced by water. And it's not just the presence of the water, it's the way this engine is turning. And once you see it, you start to see it everywhere. And it's funny because it's so, it's kind of such a big thought that it's literally like not seeing the wood for the trees almost. that we talk about these things all the time, that, why cities are here and not there, and, what the weather's like. We talk about the weather incessantly, especially in Britain. But the reason, if you go only one or two jumps back down the chain of why, the why is the ocean. And so, and just for one other example of that, which I like because it surprises people. So I learned in history class at school about the ancient Egyptians and the tomb of Tutankhamun and this amazing civilization that grew up in the Nile Valley because of the inundation. So the idea was that every year you got this reliable flood which deposited a load of really rich soil. It basically watered it for you, and then you could grow lots and lots of crops. So you could grow such a bounty that you had time and energy left over to make pyramids and sphinxes and things like that, to have this enormously elaborate culture. But that's where it stops, right? Everyone just goes, oh, there was an inundation. And it's just, okay, obviously there was an inundation. So why was there an inundation? Well, if you follow the Nile back up to its source, it's kind of got two sources. You end up in the mountains in the Ethiopian highlands. And the reason it rains in the Ethiopian highlands is because just on the other side of the mountains is the Indian Ocean. And when the currents and the wind turn to come towards the mountains, because it reverses, so the currents in that area of the world reverse direction twice a year. When they turn to come over the mountains, a lot of warm air that's got loads of water in it from the ocean is pushed up over the mountains, and it rains. It rains really, really, really hard in the Ethiopian highlands. And that is what goes down the river and gives you the inundation, which gives you the ancient Egyptian civilization. So it's because of something that is happening in the ocean. It's the ocean and the atmosphere, but the water comes directly from the ocean, just on the other side of the mountains. And so that's why ancient Egypt is there. So you wouldn't have Tutankhamun or any of the other pharaohs, these guys living in a desert, if it wasn't for the ocean, even though they almost certainly lived their entire lives and never saw it. And so when you start to look at the world like that, then you see the ocean engine is not just a curiosity, it's the framework for everything we do. And I think having that framework is important, partly because it's a sense of our own identity, right? Who are we?
Yeah.
We're people that live on a blue planet. We talk about that blue planet all the time. Isn't it about time we talked about the blue itself, not just the fish in it? Fish are very nice, but it's like talking about a person and only talking about their kidneys. You wouldn't like go into a bunch of, go into a party full of interesting people and say, oh, I met some very interesting kidneys today. Yes, this one had big kidneys and that one had small kidneys. That's what it's like talking about the fish. You're missing, they're very nice. Kidneys are very important. Yeah. And I'm not saying that fish play the role of kidneys in the ocean necessarily, but it's just they're one component of this much bigger system. And it's about time we looked at the whole system, because it's part of who we are, but it's also important for it's an important part of our life support system. So not only is it wonderful and fascinating and curious, so it satisfies our curiosity and all those kinds of things, it also is pretty important for keeping this planet habitable. So, we better know how it works, not just because it's nice, but also because it's necessary.
Absolutely. I think as you were talking, I was thinking about you kind of talk about the way that humans followed kelp forests, and I think forget what the statistic is, but I think half of the population of Earth lives within 65 miles of a coastline, just because the ocean has been that essential to our survival. And I think as somebody, I grew up in Colorado, grew up landlocked, and that made water all the more important to me for a lot of different reasons, one of them being drought. I know you mentioned Cadillac Desert, and your book is also a great place to find more books to read. You're very good at recommending other books. You mentioned Cadillac Desert, and so I think that my connection with water has always been driven by its absence, by drought, and then in how it flows back into the oceans that then connect me back to that space. But I think that understanding so much about this interconnected engine really changed the way I view all of my touchstones with it, and has invited me to explore what some of those touchstones are too, to remember that the weather isn't some random event, and to see, what you said, to look past a headline and to ask why jellyfish might be washing up on the beach. And I do think that is something that, again, that we have to sort of begin to teach ourselves, especially because this is flowing in and out of us throughout deep time, both in the atoms that accumulate in us. I was struck by the conversation in the book about coccolithophores and their calcium, and how calcium makes its way, as something that isn't highly concentrated in the ocean, into the bodies of these animals, and then back into limestone, back into geology throughout deep time, that land and ocean are cycling in and out of one another and out of us too, and now into concrete as well.
Well, oh yeah. Well, I mean, even though, I mean, so that even the water is cycling. While you were talking, I remembered to say that to think that so rivers are also two-way systems. Just to come back to the Colorado River, that people think, as it empties out, that we think it's all about the water going downstream, but of course, rivers are also connections back up. And here in the Thames, there are eels that live in the open ocean and then spend their adult years up in the freshwater streams. They come all the way up the river into the land, basically.
It's incredible.
And in the Pacific Northwest, you get salmon, that are born in the high up in the rivers, and that go out to live their adult part in the land and come back. And so there's continual crossing of this boundary.
Will you say just a little bit more about that? I think that this has been another exploration on the podcast, is a crossing of boundaries, and the eels really struck me as representative of that, because their entire biology changes to be able to live in seawater or fresh water, and to traverse the space between them over what was a shockingly long lifespan, and many miles that they migrate from the Sargasso Sea, if I remember correctly. But sort of breaching that boundary. Go ahead.
The interesting thing about eels, and there's two classes of fish that do various things related to this, is that so salt water, when it's as salty as the ocean, is effectively poisonous, and fresh water is a different kind of poisonous because it hasn't got enough salt. So our cells have salts in them, and the ocean is saltier than us, and freshwater is less salty than us. And either one of those is a really dangerous situation for a cell, because one of them will dry you out, and the other one will fill you up with water until you burst, both of which are very bad for your health. And so we don't really think of the salt in the ocean as being poisonous, but all these fish have these coping mechanisms to cope with the amount of salt that they're living in, so that they don't dry out. If you're a very enthusiastic gardener like my mum was, I'm not sure she'd do this today, but certainly when I was a kid and there were lots of slugs around, and she wanted to protect her, precious flowers, she would occasionally collect the slugs in a bucket, take them off to the garage and sprinkle salt on them. It's not pleasant, but it does get rid of the slugs, because it basically dries them out. And so, it's the too much salt is, you can see the effect that it's poisonous. So fish have these mechanisms for coping with too much salt, but then these ones that cross the boundary, the salmon and the eels, they have to basically change their entire biochemistry to go from trying desperately to hold on to enough salt to physically getting rid of it as quickly as they can. So they've kind of got to change. It's a really fundamental part of their biology, and as they swim up an estuary from the salt water into the fresh water, or down and go the other way, their biochemistry has to keep up so that they are not poisoned by their environment. And we just sort of go, oh well, fish is swimming up a river, and it's much more complicated than that. And the eels, as you say, have this extraordinary story, because they spawn in the Sargasso Sea, which is out in the North Atlantic Ocean, and they swim, or they are carried by the Gulf Stream, basically across the Atlantic towards Northern Europe. And I love the story of how they found this out, because they're tiny, right? You've got these tiny sort of fragments of life that are some type of fish, and they pop up in Europe as a glass eel, which is maybe about 10 centimeters long, I think. And they just appear from nowhere. So no one knew where they came from. So there was this one guy whose name I've forgotten, who basically took samples from across the Atlantic Ocean and got other people to help. And he measured how long the baby eels were in each of those places. And he discovered that you got the smallest baby eels in the Sargasso Sea. And as you went across the Atlantic, whatever you found got bigger and bigger and bigger. And so he came to the conclusion that they must be starting on the west and swimming east, getting bigger and growing as they went, which turned out to be the right answer. But he spent years, just on that one question of where do baby eels come from? And so, so they swim through the salt water. They get to the outpourings of the rivers. If you imagine a river pouring off a land into the ocean, if you're a fish that can sense and especially can smell, and fish do have good senses of smell, it's reeking with the stink of the land, right? Whatever was up that river, all the agriculture, the nature, the trees, the humans, all of that has kind of left its signature on the water, and that water is now flowing out into the sea. So the eels, as they're coming along the coast, effectively have their pick of the river mouths because they can smell, which one's what. And so they will pick a river and they will swim all the way up it, helped by the tide, and go through this extraordinary transformation as they go. And then they find themselves a bit of fresh water somewhere, miles inland. I mean, it's the Thames where I am is almost fresh, and you can go another 20 or 30 miles inland and you'll find the eels there. And they just park themselves in freshwater streams, and they grow. They live for 10 to 20 years. It depends on whether they're male or female. And then they get to maturity at some point. They decide it's the day, and then they swim all the way back down the Thames without feeding. They change their biology again. They swim back at depth across the Atlantic back to the Sargasso Sea, and they lay eggs. They mate, they lay eggs, and they die. So they do that whole thing once, and they're really it's a long lifespan, like you said. So there are eels in captivity that have lived for more than 20 years, but no one thinks. I think 20 years is pretty much how old people think they get. The females get in the wild, the males go back slightly sooner. But you've got this. To us, it would seem like patience, right? But it isn't. They are relying on knowing the environment, that it's a stable environment, that they can do this, they can have this life cycle because it's worked for every other generation, basically. They're evolved to take these steps, and if they take these steps, they will end up able to spawn again, because that worked for the last lot, and that worked for the generation before that, and the generation before that. And so the world is full of these like lives woven together, as well as physical features that are woven together. And we have this amazingly rich and complex system that is full of these stories.
And so many of those stories, and to pluck at this before we begin wrapping up, so many of those stories, there is that expectation that this will be the same. This has been a generational migration for eels for an incredibly long time, but all of the sudden, the waters that they swim in, quite literally, but also metaphorically, are beginning to shift and change. And we and our human scales, our human activities have begun to shift and change the way that the ocean engine functions. Is that correct? And that interconnected web of lives, but also the machinations of the ocean itself are changing.
Yeah, so the ocean has anatomy and physiology. It's quite helpful to think of it like that. It's got not all water is the same. It's not just a big blue pond that's all got the same water everywhere. It's got internal structure, and that internal structure is moving. And so there are features. There are places in the ocean where the way the water is means there's particularly, it's particularly fertile ground for things to grow, or it's particularly good feeding ground for some species. And so these physical features, which we're learning to identify from satellites and other things, but the biology just knows that they're there, So there are animals that they swim out into the ocean to feed. And I think the impression that nature documentaries sort of give us is, oh, well, they just swim out and they find some fish and then they sort of come back. And of course, that's usually not what they're doing. They are going to a known feature, or they live next to a known feature in the ocean, a known part of that anatomy, which is always there and which is reliable. And so they know they can go there and they know they can get back, and so the system carries on. And so the most of the book almost all of it is about all these, this is the story of the ocean, right? Here is how it works and all these wonderful things it's doing. And then I had to write the last chapter. And I really did not want to write the last chapter because the last chapter is where you get to, well, what are we doing now? Having established that there's this wonderful engine with all these fascinating things happening, and it's this network of physical and chemical and biological processes, and it's all kind of creating all these amazing stories, you sort of have to get to the and now what bit. And the and now what bit is not great. The ocean engine is not about to stop turning, but because it's still got energy coming into it. It's got more energy coming into it, actually, because that's what climate change is. But it's shifting the shape of the engine. And the problem is, if you shift the shape of the engine even a little bit, all these things that were predictable are suddenly not predictable. So species that base their life cycle having a predictable ocean now have to go a bit further, or they don't find as much food when they get there, or they get there at a different time to the other species that used to always get there at the same time. But also just the physics of the ocean itself shifts, and that shifts weather patterns for us on land because the heat energy is in a different place, for example. Or it's distributed differently. It's not, global warming is not about everybody everywhere getting warmer by 1.5 degrees or 2 degrees. It's about if you have more energy in the engine changes shape a bit. And it's about, so some places might get a little bit colder, some places will get a lot warmer, and the shape changes. So the last chapter is kind of a quick whiz through what we're doing to the ocean. And I think by that point, you don't need a lot, because if you already understand how this thing works, then if someone says, oh, and this happened, you can immediately see why it might matter. So you make the connections yourself, which is a much more powerful way of learning. So the last chapter is a bit of a, it's got some of the things that we humans have done to the ocean and why they matter. But the important thing is that it's not intended to be depressing. I mean, to some extent, it probably should be depressing. But the point is, if you understand it, you have agency. Yes. You can do something about it. You can change the way you think about the world. And that's the bit that's that quote by Lacey Veach that, if we won't look after it if we don't understand it, and we can't look after it if we don't understand it, and we won't if we don't care, is that you have to care first. But then once you've got a different perspective on the ocean, to come back to that word, then you know how to think about it, and then it changes how you make your decisions. And I think that's the bit that's important, that once we see it like this, then we see it in a context where we can choose what we do, and we understand the consequences of those decisions. And a lot of this isn't about, there are things that individuals can do, but a lot of it is how we see the system, how we see our society, how we see what our civilization is doing. And those civilization level decisions get made because of cultural perceptions. And at the moment, the dominant cultural perception, in the Western world, not in all communities by any means, has been that the world is there for us to use up.
Yes.
But once you understand this business of there's a limited number of atoms and the energy flows through and the atoms go round and round, then you sort of understand there is no outside to use things up from, right? No. There is no one-way system. Or anywhere on Earth, there are no one-way systems. There is no place called away. And so we have to build a civilization that fits in with the established rules of planet Earth. And this is not, I think sometimes people hear me say that and they kind of think I'm well into the one extreme of the view of what Gaia is, and that I see Earth as an organism which is looking after itself. And I don't, because I don't need to, because the physics says that this is an interconnected system. The physics and the science says that these are the rules of how it works. Like, stuff goes round and round, and there's no way of getting around that. So the only way to live for any length of time is to fit in with those rules, because there are no other rules and there's no changing the rules. This is the way a planet works. And actually, if you built a spaceship, for all those Elon Musk fans who want to clear off to Mars, the same rules are going to apply, right? You've just got a much less rich system. It's a stupid idea, basically, because why would you start so far ahead with Earth, with all this richness and all of these advantages, and then you go to a bare piece of rock and say, let's start again. And, you have nothing to start with, right? But all these problems of the energy flowing through and the stuff going round and round are even more acute because you've got no buffer in the system. So then it becomes about how we see planet Earth and actually the agency we have. And, there are some individual things, but mostly it's talking about the ocean like this, talking about this. as though this is normalizing this point of view, that this life support system is a mixture of physics and chemistry and biology. And if we understand it, if we work with it, then we can do great things. If we fight against it, we will always lose in the long term, always.
And to ask ourselves too, I want to bring in what it means. And I actually want to pull a quote from that last chapter as we begin to wrap up. Um, you said in it, we are defined by our connections of all sorts, our relationships with our families and friends, the interactions we have in our communities, our connection to the physical world around us via what we eat and what we build, and our intellectual connection to the rest of humanity as ideas circulate. The threat of the vacuum of outer space is not that it's harsh, although there is a lot of damaging radiation out there, but that it represents absence. There may be trickles of energy whooshing outward from the stars, but there are almost no atoms for that energy to act on. There is nothing to connect with. So our connections are all here on Earth. We are wonderful living components of the richest and most beautiful environment any of us will ever see. This is the beauty of being human, to be able to appreciate participating in our surroundings and communities. And I think that hopefully this ties together some of what we've discussed, because I love this idea of being a participator, of this being, as John Wheeler said, a participatory universe. And that, throughout this conversation, as you were talking about the boundaries that we cross from fresh to salt water, but also from earth to ocean, from land to ocean, and also the boundaries of our own fear of there not being an answer or asking the wrong question, that we have to find these points of connection and meaning, and to recognize our civilization level participatory nature that can change the culture of how we view some of these incredible interconnected systems.
Well, the great thing about that is it's a wonderful thing to be. This isn't what limits us. I think sometimes people see any change away from our current way of doing things as a limitation, as a sort of hair shirt exercise where everything has to become worse. And of course it isn't, for lots of reasons. But one of them, I think, is that, if you give the constraints inspire creativity. So if you give an engineer, a massive workshop and a blank slate and say, build whatever you want, they won't do anything. But if you say, well, here's a problem, we've got these constraints on it, we've only got this amount of time, do something interesting, then they will come up with an interesting and creative solution because they have to. And so actually, I think this idea of participatory life, if you like, is the spur to creativity, and creativity is the good bit. And so why wouldn't we celebrate this? Why wouldn't we revel in participating in a system that is bigger than us and that can give us so much, and that we can be so creative? We don't have to lose our creativity or our curiosity or our humanity. It only offers more opportunities to be more human. So we're not losing anything by having a different view of the world. And if we hold that as an aim, then I think we can do much better. We can choose to do much better. And it's the perspective that's going to get you there. Because if someone just gives you a list of rules to follow, that's just a list of things to do. It's like homework. But if someone gives you a framework for what it means, then you don't need a list of rules, because you'll work those out for yourself as you face those individual decisions, sometimes with a bit of help. So it is true that I set out to write a book about how the ocean works, and it ends with what it means to be human. But I think they are very deeply connected. And
Absolutely.
our view of ourselves, our identity of being citizens of an ocean planet, that's the missing thing. And once you see that, a lot of these other things make a lot more sense. But importantly, you can see how to do it, and how to be different, and how to make a human system that works better for us as well as for the planet. And that is a very optimistic thought, I think. I even though the final chapter of the book talks about things that humans have done that have caused problems, the point is that these have to be lessons. It is not too late to do better. And we can learn those lessons, and we can choose to do better. That's important. And all we have to do is choose. And sure, it's hard. It's a big project. It's going to take a long time. But if you share that point of view, if you take on board that perspective, then you've got the tool, and you talk about it, then you've got the tools you need for creating something better. And that is a very positive thing. And then we all get to celebrate living on a planet with a wonderful ocean, and we enjoy all the wonderful, fascinating things that the ocean gets to do. And we get to be human and creative and all the rest of it. And life is great. Doesn't that sound nice and simple?
It sounds beautiful, and it's all of its complexity. And I want to thank you for giving me a deeply different perspective. Just getting to traverse your work gave me a different perspective on many things. The ocean, most of all, in many ways, and I want to thank you for that, and for helping teach people and me how to remove the blinkers and ask these big questions that I think we owe it to this interconnected web of life we're participating in to ask and to learn to ask ourselves. And so I know we're running out of time, but I just want to thank you for that.
Well, you're very welcome, and thank you because enthusiasm and being interested, those are the greatest things to share, right? So we don't all know all the answers to everything, but we can all be enthusiastic and interested. So thank you for sharing that. It's been a pleasure to talk to you.
Absolutely. I'll have notes for where everyone can find you in the show notes and the books as well. But if there's anything else that you want to highlight right now, just let me and our listeners know.
Just rare earth, actually. So I've just started co-hosting a radio show on BBC Radio 4, which is it's broadcast on the radio in the UK, but it's also a podcast. It's 8 weeks on, 8 weeks off. So the broadcast schedule. So we've just finished our first series, and we will start again in May. And it's all about climate and environment and discussing what could happen and what might happen. And instead of being, just sort of a quick touch on a lot of topics, we get into things a lot more, and we have some of the hard discussions, and we try and get to answers, and we try and work out how to be human while we're doing it all. And so that's an exciting new project. So look out for more of that.
The discussions are great. I just finished the episode on rivers. I loved the episode on wood, and I loved the episode on waste with Oliver Franklin Wallace and his book Wasteland. And the conversations have been. It's been really great to hear dialogues about some of this, and to sort of get into some of the tension and the solutions and the ideas that are floating around out there. So I can't recommend it highly enough, and we'll definitely point everybody in that direction.
Thank you.
Okay. Thank you, Helen, so much. Thank you so much for listening to this episode of the Mind, Body, and Soil podcast. If what you found resonated with you, may I ask that you share it with your friends or leave us a rating and review wherever you listen to podcasts? This act of reciprocity helps others find Mind, Body, and Soil. If you're looking for more, you can find us at groundworkcollective.com and at Kate_Kavanaugh, that's KATE_KAVANAUGH on Instagram. I would like to give a very special thank you to China and Seth Kent of the band All Right for the clips from their beautiful song Over the Edge from their album The Crucible. You can find them at All Right on Instagram and wherever you listen to music.